sun is shining, it's hot out, and you have the beach on your mind. And we know just what you're craving to cool off: ice cream. This delicious treat comes in many different flavors and forms: tart ice cream, soft serve, custards, and sherbets. But have you ever thought about how these varieties are created? Well, we talked with American University's Matt Hardings. Turns out the ice crystals in ice cream determine the consistency.
What you're doing when you make creamy ice cream is you control the size of ice crystals in your ice cream. So we're going to start off with this hexagonal shape for a growing ice crystal. As you go along, you add more and more ice to the outside of your growing crystal. Eventually we get really large ice crystals.
So the bigger the crystal gets, the harder and crunchier your ice cream gets. If you don't want a crunch on your summer treat, you want your ice crystals to be small. But how do you do that? There are two ways. First, put an emulsifier in it. Ice cream is a mixture of water and fats. These two substances naturally want to separate. If they separate, like middle school kids at a dance, the water molecules will hang out by themselves on one side and will be more likely to form large crystals upon freezing due to their interactions. An emulsifier keeps the water molecules and fats mixed together, which keep the water molecules away from each other, allowing for smaller ice crystals to form. The second way to control ice crystal formation is by changing how fast the water freezes.
If you freeze your ice crystals very quickly and very rapidly, right, you get lots of little tiny crystals like this. If you let them freeze over a long period of time, you get bigger and bigger crystals at the end.
To prove that he's not just all sweet talk, Matt made ice cream 3 different ways. First, he made ice cream the old-fashioned way, in an ice cream maker.
So what this does is there is a heat exchanger in the middle, so we get this really cold in the freezer, and this needs to freeze over the course of a day, maybe 2 days, to get all of the liquid inside of this container really cold. And what will happen is this will turn and churn our ice cream as it freezes it. And this will take about a half an hour. So obviously this is a long time. And so our ice crystals out of this preparation are going to be a little bit bigger than some of our other preparations. Another way to cool down our ice cream base is to use salt and ice. And the salt changes the freezing point of the water, and so we can get lower temperatures with this bag of ice, all right, with salt in it. Now we're going to play with liquid nitrogen. So what we want to do is pour slowly while we mix it up. All right, go ahead. So I'm mixing like I did in the dry ice for 2 reasons. One is whenever you make ice cream, you want to keep incorporating air into your ice cream. That it helps with the flavor and the stability of your ice cream. But also because we want to quickly transfer the liquid nitrogen through our liquid to cool it evenly.
Sugar and fats play a crazy important role in the flavor of ice cream. Cold tends to numb the taste buds, so consuming ice cream dulls the sensitivity of the tongue. This is why ice cream has so much sugar in it. Try tasting melted ice cream and cold ice cream. The melted ice cream will taste significantly sweeter. As far as the fat goes, unless the ice cream is labeled as light, low fat, or non-fat, ice cream must contain at least 10% fat from milk. Premium ice cream, you know, the really good stuff, has up to 20% fat, which gives it a velvety, rich texture. So, we tasted the results, and Matt was right. The salt and ice cream was crunchiest, the ice cream maker ice cream was less crunchy, and the liquid nitrogen ice cream was incredibly creamy. Now, we're not saying you have to buy liquid nitrogen and start blasting your ice cream with it, but at least you now know why your ice cream treat is so silky smooth.